we would have mini viva presentations. So I'm not really sure because we didn't have any meeting to make all these dates final. So everything I'm giving to you is tentative, except for this 30th of October. So these are tentative dates for your lit review, tentative date for your proposal, also tentative date for your mini viva or mini viva presentation. So that is 17th of December. So mini viva presentation now is your, as I said, PowerPoint presentation of the proposal. If it happens that you have a really bad proposal, let's say you just did not take enough care of doing it properly, there is very low possibility that your mini viva will be good. So what you are doing in that case, you are getting your 35% from proposal, and you should be getting 20% from mini viva. So if proposal is bad, then mini viva is bad as well. So what is my suggestion is to take all this very seriously, because like there will be, even though I'm teaching and we are trying to go through all the steps, or we are trying to go, well, as much as possible through all these steps, it is up to you and your group members to concentrate and create a proper proposal and proper presentation at the end for mini viva. I want you to still understand that when you are writing a proposal, apart from getting your 35%, you are also learning how to write a proposal in a real life situation, meaning when you have to go to a company, to an organization with your proposal, it should be written in a way that you are getting offer. You are getting either the job, or you are winning the bid, or you are given a grant to do the job that you are trying to do. So it's very important. Please take it seriously. Right now, I have already 14 persons. That's good already. So I'm going to erase this and move forward.
Excuse me, Miss.
Yes.
Just for clarity, you said it. The topic that we choose for the assignment too, it doesn't matter if we're doing it for our proposal or not, does it?
You mean for my assignment too?
Yes.
No, it doesn't, because
I asked because I am still having trouble in finding a topic.
wow. And I'm assuming you are not the only one.
No, I'm not the only. I'm not the one. I don't. Well, I'm not sure, but I would think so. But there are limited projects, so I was actually in dialogue with my program director, trying
Yes.
to see if I can get um a topic that maybe I can create one of my own, or based on my liking. But what the ones that I'm interested in, they're all taken already. So.
Oh, okay. Okay, so what you do, you actually keep reading to see if there is anything that, the point is when we are choosing a topic for the assignment, we have to look at um, multiple factors. First of all, you should find a supervisor, which means if you know a lecturer that you would work with, that the lecturer will work with you, that's very important, happily. So go and talk to the lecturer first. Say like, sir, what do you think, like what you are interested, what is the topic that we could work together, and so on. It's very important that both you and your supervisor and your team members are interested in that topic, because interested also means like to some extent we should be knowledgeable, we should understand, because let's say there are certain areas in chemical engineering I won't try because I'm not good in that. So I will choose the topic which is close to me, which I understand better, which I enjoy better. So try to start from supervisor if you can. If you can get a supervisor and discuss his areas of interest, and if there is an overlap between what you are interested and they are interested, that will be the best match. The other possibility is, again, you have to read and think about topics which are doable, meaning doable in terms of time, in terms of materials, again, in terms of expertise, because it could be something in nuclear science, but we are not specialists in nuclear science, which means it is not doable for us. So we have to look at how doable is the project, how interesting is the project, also your expertise, if we have enough expertise. Definitely, we should also look economically if we can do it, because some projects require a lot of investments. And then now the investment part also interesting. If you have industry which is interested in your project, it is possible to approach them and say, look, we can solve this problem, but we are going to need your lab facilities, or we are going to need some equipment, or can you please just give us a grant of, let's say, 30,000, 50,000 or something like that. That's the other avenue. Because if there is a problem which exists in industry and you can put your expertise to solve it, that is another really good way of approaching. Because that gives you a lot of positives, because you may be working for them down the road. You show your project, look, I work in your problems. Or they may give you, we had some situations when we were able to use lab facilities, like for Seprod, we were using the lab facilities. They were very nice to us. We were solving their problem. So you have to look at all those things. So don't just concentrate on 1-2 articles and hope that you will get a project. Hopefully your department can work through. But for me, for our assignment too, it could be a hypothetical project. Like if you are finding that the project is not coming, could be a hypothetical project. The other thing is to look at projects that been done in your department, let's say last year or last 2-3 years, and look at if you can improve those projects, or look at the different aspect of the same project. Those are also possible way of getting a design project and successfully finishing it, because that's the aim. People who are here now, we have 15 of you. Very quickly, your just suggested deadlines. This is not for me. This is for the subject in general. How this goes. So just to summarize before I move forward, assignment 2, 38th of October, that's I think it's Friday. Lit review somewhere mid-November. I think I put 14th or 13th of November, 13th of November. Complete proposal. Which should include your assignment to lit review, your solutions. Complete proposal should be, is my calendar again, 38th of November. Your mini viva presentation should be somewhere like this one. I'm not sure because again, there is no agreement yet. I'm going to put 14th to 17th of December. So again, your complete proposal is 35%. Your mini viva is 20%. So your assignment 2 is 10%. Hopefully by next week, I will get the grades for assignment 1. So we have assignment 1, 10%, assignment 2, also 10%. Test, we didn't decide the date for a test. Test is normally somewhere in November. Test is 15%. Probably will be somewhere around this week or the next week after this, maybe 70. Where's my November? Let me. I have to talk to Dr. Bromwell, but probably it will be the week of 16th to 28th. So for your group could be probably 28th of November. More unlikely. This is your test day. Then there is attendance. We have really good attendance. I'm not taking attendance right now, but more than likely all of you will get your 100% for attendance because I'm actually happy with your attendance, which is giving the 10%, remaining 55%. So these 4 grades I am going to put in a system. Remaining 2 grades are coming from your department. So that's your proposal, 35%, and your mini viva presentation, which is 20%. These 2 grades give me a lot of headache because your supervisors, they don't get the proposal on time, they don't grade on time, and the mini viva grades also, department, I don't know, they hold the grades, probably they like your grades. Anyhow, these 2 grades, you have to make sure that I'm getting because otherwise you are not getting the final grade for the semester. Okay, so this is just to clarify some deadlines, also to organize your time. Remember, these things are not graded by me, but they should be done properly in order for you to move forward. Okay, guys, since everybody is here, let us see what are we doing today now. So today we are continuing talking about our assignment 2, which is your design chapter 1. Most of you have your design topics. Yes. Unfortunately, some of you don't have the topics. So please work on your work with your supervisors, work with your head of departments to deal with those topics. So I'm going to clear this. Okay, what about the teams? You have your teams already? Like your groups are organized already?
Yes, it's for me, Richard. Yeah. Yes, I have a group member. He's from the other class.
Oh, it's from the other class.
Dr. Bromwell's class, yes. I think it's on Tuesday.
Okay, okay. So
we have formed a group, but it's just
you have the teams. It's just you don't have the projects yet.
The project, yes. Yeah.
There is also sometimes projects are there and people don't have teams. There is the opposite as well.
But it's so difficult to find who does.
Who does what?
Yes, because I've spoke to persons who have done it before, and someone was telling me they weren't in a group, and it was in a time when you could communicate more easily. You see persons, so he found persons who needed one more person, and he just went into that group.
Yes, but you don't have like meetings for, let's say, all electrical students?
Well, the thing is that the groups are so small as well, so it's like it's easy to find two persons and they're limited projects. So I think there's like probably 30 odd students and there's less than 15 projects there.
Then some projects should become 3 persons.
They specify that they're limited. There's only one project that I've seen that asks for three, and I know the persons who are a part of that three-person team. So everything else is two.
Okay, okay. Anyhow, you have to continue talking to head
Yes,
of
I have been.
department.
I've been trying to get through. A little bit challenging, but
Yes.
I'm trying my best.
Yeah, that's how life goes, huh?
Yeah. All right. Thank you.
Okay. Okay, guys. So we deal with our um organizing part. So let us talk a little about our the research project and not research, design. Okay, I have to remove this now. Okay, this presentation is actually not mine. It was done for mechanical students for their design project. We are going to use just part of it, just to clarify what we want to see in our project. So once again, we are going to just look at only part of this. And the other part of this class is about our team dynamics. Like, okay, when the teams are formed, then what we do with the team. So we already spoke about this, that engineering design project process is a creative process. It's not just calculations. It's not just finding a single solution for a given problem. So it is problem solving. We have to actually solve the problem and look at the bigger picture, because again, when you are solving the problem, you have to look at other aspects of the problem, which is possible economics. You can even look at things like ergonomics. You can look at aesthetics. You can look at the cost, functionality, stuff like that, which means, again, when we are solving a problem, it cannot be just applying few mathematical equations and get the solution. As we said, this thing is not a single, yes. I always forget that we have to record these things. Thank you. Okay, so recording. So the same thing, it's if you have a research problem or design, I keep saying research, if you have a design problem, there is no single correct solution. As I was saying a little before, when you are looking at possible solutions for your design, you may come up with 2 or 3 or even more possible solutions, and then all of them can be so-called correct solutions, but they may have some drawbacks. Mostly it's economical. It could be, some of them are too complicated. Some of them are not manufacturable, meaning they are very difficult to manufacture. Or they could be above our expertise, which means we have to choose the solution that we can solve it to the end. Technical aspects, only small part of it. So we have to look at all possible aspects. Okay, and I cannot now. Yeah. So elements of design process. So you are in a process at the very beginning. You are at the problem identification process. What happens at problem identification process? You have to do some reading right now. Research phase, meaning like you have to do the lit review, looking for lit review process. Now then you have to come up with requirements and specifications. So research phase, which is looking at the literature and requirements and specifications, this would have taken care of your assignment 1. Concept generation, after lit review, you have to generate some concepts, meaning possible solutions in a form of concept. So all of this together would have make your proposal. At the proposal phase, you don't have your product, you don't have your final solution, you have the concept. After that, in semester 2, you would have go for a design phase. All of this, maybe up to here, would have taken your semester 2. You would have designed your solution to your design problem, whatever it is. It could be, you can write a program, you can put together physical components of your design. If it is that drainage system, probably you will have your drawings. You may do some simulations if there are programs which allow for simulation. In some cases, I don't think we all end up creating prototypes, but in some cases, after design phase, we actually create a prototype. If you have a prototype, then you have to test the prototype, which means you are changing some variables, you are collecting a data, you are analyzing the data from that prototype. Let's say if you are changing the voltage or current, or you are changing temperatures, you are making some changes, and you see how your prototype is responding to it. Like one of the groups was designing hydrogen fuel radial engine. Hence, for that one, they have to actually get that radial engine after their modifications. They have to get that hydrogen fuel and test how that engine operates, maybe at a different fuel and oxygen mixture, I'm assuming. So at the prototype phase, you do a lot of testing. If the prototype is doing what you are expecting, then you would have moved forward. If it doesn't, you are going back to concept generation, because if the prototype shows that certain things are not working, or what you are expecting you are not getting, then you would have go back, which means it is good at the concept generation stage. Maybe I have to use a different color. Let me use white. So at the concept generation, oops, not working. Yes, white is working. So the concept generation stage, you have to spend a lot of time to create a reasonable concept, because then you are going to go through 2 stages and then find out that some things were not taken into consideration. You have to go back and then come again. So this process could be multiple cycles, that when you are going prototypes to concept, it could be even from here, maybe you did not specify your functional requirements properly. You may go back and start back. That's why we are saying design is an iterative process, meaning like you may end up going back, making some corrections, coming back. So anything you do right now is not written in stone. Towards the final presentation, you will have gone through these stages maybe multiple times. That's if you are working effectively and you are not waiting until the May the 5th to start looking for your materials of the prototype. At this stage, once the prototype testing of the prototype is finished, you would have go for your major project presentation. That will happen in May 2021. So you have to constantly work. You may find that you are making some modifications to your requirements. Some modifications may happen to your concepts. I have been in one of the presentations for mechanical students when they were presenting a prototype which absolutely did not do the job. It didn't work. So they had this grand idea. They actually created a prototype. They spent months to create a prototype, and then it didn't work. So of course they had to present because there was no more time left. But the point is, in a real life, they should have done that design phase. This phase should have been done properly. Now we have simulations. We have some other ways of testing before we go to prototype, because prototypes are expensive. And if they are not working, you have spent all your money. Hence, you have a project which cannot be finally presented. If it was an industrial situation, for major project, we end up presenting because we want to see the approach of the students. Of course, we would be happy to see a positive result at the end. About money, I'm not sure what is happening this year. Normally for each student, university has about 10,000 Jamaican, if I'm not lying, for your project. So 10,000 Jamaican dollars for project, which means your project budget, if you are buying specific materials for your project, is probably 20,000 or 30,000, depending on a number of students. However, if it happens that for your project, based on your concept generation here, you already know your budget. That's why budget should be in your proposal. You already know how much money is needed. You can present this to your department, and department has some other money which is for materials and so on. They should be able to buy it for you. However, if at the concept generation step, you fail to identify exactly what do you need for a successful design phase or a prototype phase, what happens, students are coming very late in a semester 2. It could be March, it could be April, and they say, Miss, I need these materials, or I need this type of testing. You have to understand that university have to order those things. Those things should be shipped to Jamaica. They go through the customs and so on. When all that happens, you are already in maybe May, June, maybe in year 2022, not 21. 1 year we made an order and we get it 2 years after we order the thing. Of course, that was an exception. Normally it takes a couple months. So your list of what you need, let's say you need some devices, you need some chemicals, you need some, let's say these hydrogen people, they will need a cylinder of hydrogen, or they need a hydrogen generator. I think UTech has a hydrogen generator. We just don't get the correct purity, I think, something like that. So you have to know, like, okay, what do I need? Is it in UTech? If it is not in UTech, how we are going to get it? We order it, we borrow it, we buy it. So remember, the amount of money given to you is quite limited, but some departments have other monies that can be used for these projects. Okay, this is giving you a little insight moving forward. Okay, what is happening here? Yeah, this thing doesn't allow me to move forward. Well, here is talking actually about what I was just saying. Your cost of project implementation goes quite exponentially up. So at the beginning, you are just doing paperwork. Down the road, you are getting your prototypes, you are getting your testing equipment and everything. So it becomes more and more expensive towards the end. So right now, what you should do, you have to identify your problem and needs, determine requirements. We have to see if the requirements are satisfying the needs. If not, then you have to determine new requirements. If yes, you continue. So requirements would have been the functional requirements. Yeah, this thing now. Okay, so first you have to identify, deal with your problem. Collect the information, interpret the information, organize the needs, like what are the needs. Remember, let's say your problem is that water drainage in an area. So you have to collect information about that area flooding. You have to collect information about the design of the roads and the drainage, what is there already. Maybe you have to have some information about soil composition, drainage people. What else you need to know? No answers.
Miss, I didn't hear you.
I'm saying, like, what kind of information you have to right now collect in order to successfully go about your problem solving?
Miss, so we were looking for the current drainage system plan that they have, the agency has, but we didn't get that. So we have to know that, and we have to know the amount of water that is estimated to flow in that area over the number of years, and how much we expect it to increase by, all of that stuff.
Exactly. So that's where the collect information is. Some of that information probably comes from NWC. They are the one responsible for drainage.
NWA.
NWA. Okay. So you have to get NWA drainage drawings. The what is now available.
Mister said they don't have any.
They don't have any, which means you guys have to physically go and make some observations and take some pictures. And some, at least hand drawings. You should know what you are looking at, like which section of that area you have to do design for. Maybe there are some area drawings, you have to get them, because right now you cannot say, oh, they don't have it. So what you do next? You have to then create your own information. Then you have to get maybe annual rainfall and amount of the water that that drainage system should handle, and probably the maximums, minimums, hurricane season, dry season, and so on. Then you have to interpret all of that information. Also, collecting information means not that what exists there, but what kind of drainage systems are possible. Meaning other people, how they handle similar situations in different countries, not in Jamaica only. You can look how they do it in Jamaica, how they do it in different countries, how they do it in different tropical countries, and so on and so on. Then you have to find out exactly what's the need. Okay, we need to have a more efficient drainage system, but we have to know exactly what that drainage system should handle. Is it stormwater only, or it should be stormwater and the thing, residential? People?
Yes, miss.
Is it stormwater only you are talking?
No, miss, it just said to fix your drainage issue. It didn't say stormwater or anything.
Which means you have to find out all of that, because what is drainage issue? Is it storm drainage? Is it residential drainage? Is it some swamping some areas? So you don't really know your needs. Like, you don't know the functions that your system should perform. So you have to now organize your needs hierarchy. You have to find out what is the most important or least important in that list. Determine relative importance of needs. Like, you have to find out which type of water. Is it storm water? Is it gray water that is creating your problem? And then how much of each is there, and how to approach the solution. If there is no drainage, that's why they have no drawings. That place has no drainage whatsoever.
Miss, yeah.
Wow. Okay. So and this goes not just for the group with the drainage
Sorry, miss.
problem. Yes.
I was saying, when we contacted them, they were saying that there was some plans, but the plans were on paper, and then when they were transferring it to the computer, I think something got lost or something. That was the issue with them. So that said that we should contact NRCA
And get those paper plans
business.
if they give you. Okay, so you have to have a proper letter from university or from your supervisor, because just because you send an email, they are not going to give you plans. You have to now talk to your supervisor and get a proper letter from university, probably with a letterhead, asking for assistance with those drawings, because those documents are not easily available to the public. Okay, guys. So once and these are kind of needs hierarchy. What you have on the screen, let me make it a little bigger. Oh, can't. Okay, so what you have on a screen, you have actually design, which is to design a portable audio device. We have a lot of them. So you are seeing needs hierarchy for that portable audio device. You are seeing that it should be portable, it should be easy to use, and it should be high quality audio. But then under that, we are now clarifying, okay, what means portable? Under portable, what we should put? It should be lightweight, it should be small, it should be ergonomical, it should be it should be used in different environments. And then when we say environment, what we mean, it should be outdoor, running shock, if the runners are using drop resistance, because if you are running, it may drop as well. Water resistance, it was raining and the device gets wet. So what we are doing, we don't have the device yet, but what we are doing, we are actually looking at hierarchy. Okay, like what kind of needs are there? What kind of functions are here? The functional requirements, easy to use, should be portable, and it should be high quality audio. Under those, we are trying to figure out what else this device should be able to do. What we mean when we say portable. Now, these things happen when you as a group, you sit and discuss. So you discuss and say, okay, what am I expecting from saying portable? Now, and then high quality audio, what is it? Low distortion or low noise. It could be some other things. Here, you see this thing is so old, CD audio format, MP3 or CD audio format. Now probably there are some other formats too. Nobody is dealing with CDs anymore. Okay, so next, so the problem statement, yes? Drivers have difficulty seeing obstructions in all directions. This is the need. Just like you are told that in Huondale area, there are multiple flooding cases. So people in Huondale area are kind of losing or the properties are getting damaged and so on. So that is your need. Need is, there is a flooding. Objective is to design a system, in this case to avoid accidents, in your case to avoid floodings during heavy rains or during hurricane season and so on. So in your background, you have to bring that need. Like when you are writing the background for the design assignment, you have to clearly discuss your need. Okay, this is the area. There is multiple floodings there. There is, basically there is no drainage system. So the water is removed by surface flow or something like that. So all of that should be discussed in your need. Now then, what's the objective or what's the purpose of your design? To design a system to avoid accidents. In this case, they don't specify what kind of system should be designed for drivers. Meaning, is it something that will give you sound signal, something that will give you light signal, something that will break it even without the drivers. We know those systems exist as well. When the car comes too near to an obstruction, it just breaks because driver at that point kind of loses the control of the car. Okay, so we are looking at next, you are identifying requirements design must satisfy to be successful. There are customer needs. Let's say what the customer wants. In your case, your customer wants to have no flooding. Or in this case, the customer wants to have less accidents. And then there is engineering requirements. So here comes the technical aspects. So you as an engineer should decide that what your design should be able to do. So those are your technical aspects and the performance requirements. Performance requirements will be your functional requirements. Let's say your drainage should not obstruct the traffic on the road. Your drainage should be able to carry the water, but it should also probably filter the mud and stuff. So all that soil and gravel doesn't go through the drainage. I don't know how you are going to do that, but like I would have assumed those should have been possible functional requirements. So the engineering requirements, they have to satisfy needs. Let me go to a next one. So the performance, so when you are putting your engineering requirements, you have to look at functionality. We call them functional requirements. Let's say, look here, these are examples of functional requirements. Will identify skin lesions within a 90% accuracy. So this is a device which should identify skin lesions, or should be able to measure within 1 millimeter. In the case of drainage, should be able to carry, I don't know how many liters of water per hour. So that's a functional requirement. Should, without flooding the area, let's say certain liters of hour, that will come from your research, like how much water, maximum amount of water per hour the system should be able to handle. Reliability should be operational in 99.9% of the times. Lifespan about 10 years. Energy, average power consumption of 2 watts. Peak current draw of the 1 amp and so on. So these are your performance and functionality. For each project, there will be different functional requirements. So you have to identify what are the functional requirements for your project, meaning when your project is finished, what it should be able to do. These are kind of IEEE requirements. Normalized, complete set, consistent, bounded. I'm going to leave this out. Okay, let me go back again. Functional requirements are part of your assignment too. So make sure that you have list of functional requirements. Some people put up to 10. We would like to have 3 or 4 at least. What kind of functions your design should perform. Now, once you are going for your functional requirements, you also deal with your constraints, which is next heading in your assignment too. So what kind of constraints are there? Major constraint is definitely economic, meaning you cannot have extremely expensive project because nobody will will put money in it. It could be environmental. Let's say for this drainage problem, there are already houses and roads there, so you cannot move them. Hence, you have to design around it. First. Second, you cannot create excessive environmental pollution or damage to the existing environment. So this is a constraint. It could be ethical and legal constraints. Let's say, I'm not sure how this will apply to the drainage situation, but you may need to take, let's say during some constructions, roads are widened. That is encroaching into some people's land space. Hence, you will have legal issues if you are going to use the citizens' land space. In that case, normally government buys the land. It could be health and safety constraints, meaning you have to take into consideration safety, definitely. The other constraint could be manufacturability. Your design, if it is too complicated, then it cannot be manufactured. Hence, you have to take that into consideration. Normally, it is not in this list, but the constraint is also a time. You may have time constraint because you have to finish your design within this year. By May, your final project should be on a table. Hence, you are constrained with time. So economical, environmental, ethical, there will be some regulations. Those are constraints as well. Political and social. Yeah, this one is very serious for us too. And then sustainability. This one, I'm not sure how this may be applicable to the designs we are discussing so far. Now, there are certain standards that you have to definitely safety standards. There are testing, reliability standards, and so on. So when you are creating your product, you have to take these standards into consideration. For civil people, probably you have to take into consideration your codes, building codes. Building codes will also require certain type of documentation. If you are programming, you should know specific programming languages. In some cases, you may need to learn a new language. In some cases, you may learn new testing methods. So you should know what is applicable to your design, and you have to work with it. Let's say there are simulation programs. You have to know which program and you have to learn how to use it. There are codes, you have to apply them. There is type of documentation that you have to prepare. I think civil students are preparing some very serious drawings, documentations for their major project. Okay, so I'm going to stop here because this part now is about generation of the multiple solutions. I mentioned it today a couple times. So we haven't reached this stage yet. So we are still in a process of kind of forming our problem statement. So I'm going to stop here. We are not going to continue. Okay, so to summarize what was said and move forward, I want you to have a background for your problem, design problem. Background should be a page which will describe your design problem. Let's say in a case of drainage project, this should describe the area, describe the fact that there is no official drainage system, and the type of problem residents are facing, number of times the floodings per year are happening, and then maybe you have to know what type of I don't know, you have to probably talk about amount of rains, the seasonal conditions, also projected, like what is going to happen based on global warming and so on for next, let's say, 10 years. So that will give you a background. That will also describe the need. Then you will have your problem statement. So in your problem statement, you have to say, like, the aim of this design is what? Or the aim of this design project. Is to do, like, is to create what? Because you have to create, you have to optimize, you have to redesign maybe, yes? So depend what you are doing here. You are optimizing, you are redesigning, you are proposing solution to the problem. So that should be here. Then after that, you have to decide what are the functional requirements of your design. If it is possible, please include the specifications as well. Specifications, you have to discuss it with your supervisors. At this point, I cannot really give anything else. And then you have to have your constraints and limitations. So the functional requirements, this is kind of like about 3-4 points. Specification, same thing, 3-4 points. Constraints, limitations, same. Constraints, limitations, economical, time limitations. There could be regulations, legal issues, could be ethics, aesthetics, safety, stuff like that. So at the end, you should have some references. Where the references may be, when you're stating your problem, probably you may have some references here. When you are going for your specifications, maybe you have to refer to some building codes or IEEE codes and all kind of stuff. So those things may come here in references. If you are designing a let's say you are designing an engine or you are redesigning an engine. For that one, probably again, you have to, in problem statement, you have to talk about, let's say, radial engine, what it can do, what it cannot do, or it is, so all of that will require some kind of referencing. How many? At least 2, because now it's not so easy to get references. Your references are coming from technical journals. They are coming from companies. Here, people, I'm not sure if I spoke about that last class because I'm teaching 2 groups. It kind of mixing up. You can also reference your communication with other engineers. Let's say this group, which is going for a drainage. They spoke to people from NWA. So they can actually say that there is a plan which was not used or which was not materialized. So where that comes from some kind of communication. So when they are speaking about the plan which exists on a paper, but it was never materialized, and now there is a need to redesign, or there is a need to optimize that plan, you have to say, how do you know that? Hence, I want you to make sure that if you have communication, if you have emails and you're writing based on that, in a references, you can actually refer to it. There is APA referencing for communication as well. Which means your communication could be with an engineer, it could be with a specialist, it could be with even with your lecturer. So if that information is coming from any kind of communication, verbal communication, on the phone, on the email, and so on, you can reference that. So on the title page, all of this is making your chapter 1 for your design project. This is also making my assignment too. Due October 30th. I keep writing 2020 because you can say legally October 30th, every year has it. Where we go. So from here, whatever little time we have now, is it little time? No, not yet. I'm going to give you some break and we are going to look at team dynamics, team forming and so on, because some of you are now in a process of working as a teams. You may say you did it before, but now when you are doing a project, we are looking at what should happen with you guys as a team. Next week, we are going to talk about lit review. So our topic for next week is lit review. So you are finishing this, so we are ready for the lit review. So 10 minutes break and we are coming back.